Go.
5.5.
Okay, 5.
Yeah, I was right.
We are going to approximate that binomial distribution back in chapter 4 using the normal. So approximate the binomial distribution which was in chapter 4 by using the normal distribution. Remember when we were doing that by hand, we had to do, like, say the probability, say you're taking a 10-question multiple choice test and you wanted to get at least 8 correct, we had to use the table and add it, or maybe 6 correct, and you had to use the table, add up 6, 7, 8, 9, 10 successes. Or if we could use the normal, it would just be much quicker. So this is just kind of a shortcut instead of using that binomial. But I do want to review the binomial real quick. Review binomial. If you remember, the binomial distribution was when we only had, each time we did an experiment, there were only 2 outcomes, success and failure. And where n was the number of trials we were doing, p was the probability of success, q, probability of failure, and x represented the number of successes. And our formula to get the probability of x successes was the ugly one. NCX multiplied by p raised to the x multiplied by q raised to the n minus x. And then we did do it with technology, and I'll review that real quick. We had the binom PDF, where you fed it n, p, and x, and this would give the probability of just x successes. And then the binom CDF, if you fed it n, p, and x, would add the probability starting from 0 all the way through whatever x number you put in. So we are going to do this first question both ways, using the binomial and using the normal. So example 1. Say we've got a 20-question multiple choice test. Each question has A through E, with only one being correct. Find the probability that you get exactly 10 correct. So we'll start with an easy one. And let's do this one with technology, because it'll be a little quicker, because I want to get to the meat of the lesson here. So I'm only looking for exactly 10 correct. Should I be using the binom PDF or the binom CDF? PDF. So you remember that. Binom PDF. We feed it number of trials first. How many trials am I doing? 20. What is the p-value for this situation? P is the probability of success. Where's 0.2 coming from?
Because A through E, which means 5.
5, and only one's correct, so 1 out of 5 is 0.2. That's 1 out of 5. And then we are looking for exactly 10 correct. So what is the chance of just getting 10 correct? No more, no less? 0, 0, 2. All right. Now, in order for us to use the normal distribution to solve this question, first we have to make sure our sample is big enough. So, to use the normal distribution in place of the binomial, the sample must be big enough. Yes? Yeah? Okay. Two things have to happen. Your n times p has to be greater than or equal to 5, and your n times q must also be greater than or equal to 5. And we'll check that in a minute. So if both of those are equal to 5, you do get to use the normal distribution. But in order for us to use the normal distribution like you've been doing, you have to know the mean and the standard deviation. The mean of the normal distribution is n times p, and the standard deviation will be the square root of npq. So, after that, after we decide if it can be used, there's one other thing you've got to do. It's called making the correction for continuity. Can we use it on this one? Did you check it? We can't use it, it's too small?
4.
Oh, it's 4. Of course. Should have put it at 30. So the correction for continuity. Changes a whole number into a range of values that can be shaded in under the normal curve. So example 2. We're going to make the correction for continuity for a couple different problems here. It has 3 parts to it, so yes. So our probability question that I asked was the probability that x equals 10. And remember, for this binomial distribution, I had a 10-question test, so my smallest x value would be 0. I get 0 correct. I get them all wrong. And then all the way through, I could get all 20 correct. Not that 10's going to be in the middle of this thing, but I'll just put, let's say 10's right here. In order for us to use the normal distribution, we have to have a shaded region. Well, if I just say 10, I don't have a shaded region. But now we got what's called make the correction for continuity. What values on this number line round to 10? So how far below 10 can we go where a number would still round to equal 10? 9.5. You everybody agree with that? 9.5. How far above can you go?
10.4.
What about 10.49?
Where are you getting this?
Rounding rules. What numbers round to 10?
Oh.
Got it?
10.499.
Exactly. So where are they?
5. Yeah.
9.498.
Wrong in 9.
Datable.
How about anything under what? 10.5. See how tricky I was there? Dashed in the line there, solid the line there. Not that it matters, because we would be turning both 9.5 and 10.5 into z-scores. We would still be equaling 10.5 as our z-score number. But in order to rewrite this, in order for us to do the normal distribution, we would change this x equals 10 to anything greater than or equal to 9.5 but less than 10.5. That's called making the correction for continuity. We need to change the whole number into a shaded region. Okay, what if my question said, what's the probability that you get less than 3 correct? Well, you need to include all values that would round to 3. That whole number is going to get changed by a half. It's either going to go to 2.5 or up to 3.5. So what I want you to do is put the bar around 3. Now decide, is 3 included in my question here when I say x is less than 3 correct? That means we don't want anything shaded as part of the 3. So we'll be shading below the 2.5. So the correction for continuity would be to change the 3 to anything under 2.5. So make the bar around the whole number, decide if the bar is included or not, and then shade above or below depending on what the question asks. Let me do another one so you can, then we'll look at the two of them. What's the probability that you get at least 6 correct? What does at least 6 mean? As an inequality symbol. 6 or more, so that would be greater than or equal to 6. So before we even start, I know that the 6 is either going to be a 5.5 or a 6.5. It's got to change by a half. So give yourself a 6, give yourself the 5.5, and the 6.5. So the first thing you decide is, is the x included? Do I want to shade inside the bar?
Yes.
Yes, so I do shade inside the bar. And then am I shading above or below the bar? For greater than. Above. So that means the shading blows by that edge. So what does the 6 get corrected to? Where does the shading start? 5.5. So, start with the whole number, put the numbers around it, then decide if it's shaded in or not. Jonathan?
So these are answers?
These are answers, yes. All we're doing right now is making the correction for continuity, and then we're going to do the probability will be the next step. So they're baby steps here.
Isn't like a hard concept, but it's kind of weird when they give you like X is like less.
I know. Can we do, maybe we should do one more of those, just to make sure?
Well, no, I
No, you're good?
Yeah,
Okay.
I think we get it.
All right.
It's just weird in general.
All right, so the steps for using the normal to approximate. It's a 4-step process. Let me give you all the steps right now. So on your note card, you're definitely going to want to have these 4 steps written down. And you're going to know to do this because the question is going to say, use the normal distribution to approximate the binomial if possible. So you'll know to come to this section on your note card. So it's pretty obvious when to look for this. Okay. The first thing you want to do is check to see if your sample size is big enough. Check that sample size is big enough. And I told you how to do that already. That's the n times p has to be greater than or equal to 5, and the n times q has to be greater than or equal to 5. If not, then you have to go back and use your binomial formula. If they are big enough, you continue on. Find the mean and standard deviation for the normal distribution. Mean is n times p, and standard deviation is the square root of npq. Then you write the probability question and make the correction for continuity. As an inequality, and make the correction for continuity. If you forget to do this, it costs you 2 points. And then once you've done all that, now it's turn your x values into z-scores and use your table to find the probability. Find z, or possibly 2 z's, and use table to find the probability. So if we check our example 1, Sam already did. He said we can't use it because the n times p was too small. So our example 3 will be to, we're on 4. Example 4 will be to check example 1. See if it's big enough. If it is, we're going to continue on, but Sam already said no. So n was 20. The p was 0.2. That came out 4. Sample's not big enough. So the normal will not be a good approximation for that probability that we got. So I'll give you one that is. Okay. Are you ready? Here we go. Hopefully one question will do it for you. Sample 5. found out that 29% of the American population thinks that they will be offered a trip to be able to take a trip to the moon.
Does it need a lot of room?
Yep.
She did say it wasn't real often.
Leaving a lot of extra space, I'm pulling to keep it.
You are going to randomly select $200 people. Can you find the probability that at most 65 people say yes? Yes, I think I will see people be able to take trips to the moon. Use the normal to approximate the binomial if possible. If possible. So this little sentence is what's it's going to tell you to come to this section on your note card and follow those 4 steps. And I want to see all 4 steps on the test Thursday. So first, the first step is to check to see that the sample size is big enough to make it normal. So that's the n times p and the n times q both have to be greater than or equal to 5. What's my n in this problem? N is how many?
No, that's 200.
That's 200. And p is, what's the probability of success? 0.29. And then q would be 0.71. What's the 200? I really only got to check the smaller one. What's this number equal to? 58. So this one's definitely going to be, so this is going to be okay. So yes, let's move on. They're both okay because they're both greater than or equal to 5. So the second step. What was the second step? Find the mean and standard deviation for your graph. And I would actually make the graph because you're going to come back and shade on it anyway. So the mean is n times p. We already did n times p. It was that first check. So our mean is 58. Standard deviation needs to be calculated. It's the square root of 200 multiplied by the p of 0.29 multiplied by the q of 0.71. What did you get? 6.42? Okay. Now our third step is to write the probability question and then make the correction for continuity. So we need to write the first thing. What does at most 65 mean? Less than 65?
Less than or equal to.
Less than or equal to 65. Now we've got to either change that 65. It's either going to change to 64.5 or 65.5. Let's see. So here is 65, approximately. Here is going to be 64.5. Here is going to be 65.5. Not that I can fit those in there. So the middle was 65. So, do I shade in the 65 bar? Does x actually equal 65? Yes, so I shade the whole bar in. Now, which side of the bar am I shading? Because we've got x is less than or equal to 65. To the left. So how far did the shading actually reach? 65.5. So we're going to correct that 65 and make it 65.5. And I'm not putting the equal to, because if we equaled 65.5, it would go up, but it doesn't matter. Because we're going to change that to the z-score no matter if I put less than or equal to in there. I don't care, I won't mark that wrong. Okay? Okay, now we're ready to turn 65.5 into a z-score and then use our table. Our fourth step. So the z-score for 65.5. So it's 65.5 minus the 58 divided by that 6.42. This is z-score. 1.17 out to two places. Now am I going to do a 1 minus, or am I going to keep the value? What's going on here? You're just going to keep that value because it's the area behind, so it is the data value on the table. So if you look up 1.17, what is that area?
8, 7, 9.
There you go. So there's a little bit more involved in the problems, but you can see we kind of been doing the same stuff. Turn stuff into z-scores and use that table. Your assignment? Well, that wasn't too bad. Let's see. Yes, your notes are due today.
Are we gonna be able to get those like before?
After 4th hour.
Okay.
Okay, page 241,
I hope they see that it's bad,
5 through 12, 16, A through C, 17, A through C.
No, why?